Cool. Well, thanks for coming. There's a QR code at the top if you want to download a copy of the slides. It'll take you to misconfigurationmanager.com. There's a copy of the slides there labeled SOCON 2025 if you want to check it out and look through kind of some of the other techniques that we'll be talking about today. So I'm Chris Thompson. I'm a senior security researcher at SpecterOps. I've been working here for about 4 years. Kind of got into attacking SCCM on an op. Needed to find a particular user, execute code on their machine, ended up writing sharp SCCM. And then Garrett, me, and Dwayne wrote misconfiguration manager to kind of track a lot of these techniques that we were coming across because it was hard to remember all of them.
I am Garrett Foster. I'm a senior consultant. I've been here, it'll be about 2 years in July. I'm the author of SCCM Hunter, and he mentioned misconfiguration manager, but I got into SCCM research because of him. The initial blog post where he mentioned the takeover, and then I actually took it into kind of a frustrating client that we've been working on for a long time that had been kind of more hard and restrictive, and then his research ended up being like the easiest attack I'd ever performed, and that kind of sent me down the rabbit hole. So, and here we are today.
So I want to talk about what this talk is and is not about. So we've talked about SCCM fundamentals before in a couple talks, so we're not going to go over the basics. We're not talking about specifically how to execute these attack paths. If you want to check that out, we'll have a ton of resources for you. We're not talking about detection specifically. I know Josh Prager talked about detection in a talk earlier today that will be recorded that you can check out. What we are talking about is preventing known attack paths in SCCM. So this is kind of an attempt to be like a one-stop shop, step-by-step guide that you can use to prevent the most critical attack paths in your environment. We're also going to talk about how these configurations can be misconfigured and how attackers can bypass them if they're not carefully set. And then we're going to just provide some context about how we've seen this in real-world environments as well. So who's this talk for? Defenders who want to understand these attack paths, make recommendations to their operational teams, sysadmins to implement them, and offensive practitioners who are just looking to find out, what to recommend as well as how to bypass some of these security features in their client environments. How many defenders in the crowd, just out of curiosity? Okay. Offensive folks? A little more of you. Any SCCM admins or former SCCM admins? We got one. All right, this talk is for you.
Okay, so last year at the SOCON is when Chris and Dwayne initially published Misconfiguration Manager. So the idea that we went into with this project was we wanted to have kind of like a one-stop shop of all of the different tradecraft that had been published, because at the time it was kind of sporadic and spread out, and we didn't have kind of like a central knowledge base for things. So the work we put into that was to put all in one, and we wanted it to cover kind of the entire spectrum, offensive, defensive, how we can fix all of these things, and then kind of provide like a taxonomy to name all the different pieces of that convention. A lot of it was inspired by the work that Will Schrader and Lee Christensen had done with the Certified Pre-Owned white paper. So we kind of drew inspiration from that in how we were going through all of it. Kind of did a lot of it based on the minor attack framework. So some of the techniques that we had identified, we tried to map to those frameworks since it's kind of familiar to everyone. And like as consultants, when we're talking about something, if we can point it to the minor attack framework, that's pretty helpful. And then I believe it was a couple months after we initially published the repo, one of the asks was, is there a way to just kind of like find everything all at once? Like, this is great that we have this knowledge base, but I would like to just have like this catch-all. And then you had wrote the PowerShell script that you can run from the site server in an admin context and kind of like list out all of the things that the environment's currently vulnerable to. So the taxonomy, the idea behind it was like, we've all had the conversations like, well, how did you own them? Like, what did you actually run? And it turned out like, well, I've coerced the site server, I relayed it to the database, and I ended up adding an admin, and I did all this. That it just didn't really roll off the tongue that way. So we figured something like, well, I ran Takeover 1, and we have something published there where you can reference it and you would know all the steps to that. So a lot of the techniques that we talk about, there's the attack and the defensive side of things. So if you're ever like referencing something that you had done in an assessment, you can point to it that way. Probably the most common that we will use in reports is like Takeover, cred, recon, all these things kind of like part of that that attack lifecycle. So kind of the biggest thing with SCCM is arguably takeover. So there's a kind of a couple pieces to the puzzle with this thing, and essentially it's a way for us to gain complete control of every client that is enrolled in SCCM. So how can we take that over is by obtaining the full administrator role in that service. So if we can grab that full administrator role, or actually that role in any site, this is something that Chris had found while he was down a pretty big rabbit hole trying to find, is there a way for us to go from a lower permission and elevate all the way up to complete control at the central administration site level. And kind of like during that process, he found out that at the lower level, if you can add an admin, that admin gets replicated out throughout the entire site. So now if you own one site in the hierarchy, you own the entire hierarchy because of that replication. So as far as like takeover goes, why should we care about it? There was, I think it was DEF CON 20 that Dave Kennedy initially like showed, where they managed to compromise the service and they were just pushing out shells and they made it rain shells, which is always fun. So we have that kind of like command execution everywhere, but there's more to it. There's kind of some nuance that you can do once you have that full admin. There's some features that we'll touch on in a bit. There's a blog post that I think Diego had posted about CM Pivot, some of the opportunities we have there for discovery and authentication coercion. We can run scripts, packages, applications, kind of you name it. And then we can actually cause some availability issues with the applications that are being deployed, including software product or security products. So with Takeover, there's kind of like some key concepts that go into this. And the biggest one, I think when you were doing the research, you had found, you're in that massive book, right? Where you were talking about and
SCCM Unleashed.
Yes, yeah. Unleashed, yeah. And kind of like the blurb that he'd found was like that the site server's domain computer account in Active Directory is required to have local admin over every single role in the hierarchy. So that includes the remote site database if it's hosted there, distribution points, management points, you name it. It has to be admin, and it's part of the requirement there is it installs the actual service and then it monitors the health of that service. So it's required. It's the only way that the actual service works. And then the extra piece is that that computer account is also required to have the sysadmin role in the corresponding database, which means that if we have that permission, we can make any type of modifications to it and ultimately elevate our permissions. So yeah, the kind of the crux of the issue here is authentication coercion. I think Lee and Rohan had talked about that extensively at their talk earlier this morning, if you had caught that. But essentially what we can do is we can force this site server's computer account to authenticate to arbitrary endpoints. And since we have the knowledge and understanding of the roles required for that site system, we know that we can force it and then direct that authentication to the site database. And then we can grant basically any principal we choose to that full administrator role and grant them complete control of the hierarchy there. So on the defensive side, if you can prevent NTLM authentication with these credentials, you can significantly reduce the risk for your environments, because a lot of this is focused on authentication coercion with NTLM. So there's a number of them. I think we are missing 9, but we'll get there one year. So kind of the most common ones, I'm not going to touch on them all. It's kind of excessive, but Takeover 1 is kind of the one that I just touched on, where that site server is required to have that sysadmin role of the remote site database. The rest of them we have, for the most part, we've seen most of them in production. I think Takeover 2, which is just relaying to a separate service, SMB for the site database. But for the most part, we've seen all of these in enterprise environments. So there's a number of them, and so there's plenty of different ways to take over SCCM.
All right, so we're going to demo kind of the easiest one to perform for you. It takes about 30 seconds if you know where the primary site server is and the site database is. So here it goes. So we're starting off in a lab environment. We have 2 users, lab admin and lab admin for the domain. We're going to try and add a low priv user to this list here. All right, so the first thing we do is we use SCCM Hunter to grab the domain SID for the principal we want to add to the full administrator role. and it will spit out this nasty SQL statement that we're going to use on our relay server. This is what is going to add our user to the database after we connect to it with the site server's credentials. So we're going to copy this over, and we're going to start our NTLM Relay X server. We're going to target the MS SQL service on the site database. Then we're going to go to another tab. We're going to coerce authentication from the primary site server with Petit Patam, which is like a won't fix issue that Microsoft has said they will not fix. So very easy for us as attackers. We can see our authentication as the site server to the database succeeded. And then if we come back to the configuration manager console, we can see that our low priv account is now full administrator. And it really is as easy as that in most cases by default.
No, nice. Okay. Okay, so we wanted to provide some kind of like context around some of the post-exploitation you can do once you've compromised the hierarchy. Like obviously we know about the rating shells and whatnot, but so this is kind of an example from an assessment. I recreated the issue. The ask was to gain some type of access into AWS, and that's kind of what we've run into with SCCM. Is there's a lot of opportunity to get into user context. I know from my previous experience, typically finding the users that we need access to, it can be difficult understanding what systems they're logging in from, but that's pretty trivial with this service because it monitors that automatically. So we can query for it and understand where they're signing in from. But in this case, I kind of took like a nuclear approach to it. So there's a tool called CM Pivot, and it's like Configuration Manager Pivot, where the idea is it's available to do reconnaissance for services. Like, so if you're the admin, let's query registry to make sure something's correct. Well, some of the features are to query the file system. So it accepts wildcards. They wanted AWS credentials. So I threw wildcards in for the path that we know that AWS credentials exist. And then I queried the entire enterprise, which was a little over 7,000 systems. And ultimately at the end of that query, I ended up with like 800 unique credentials to AWS. So I think that objective was accomplished at that point. Another example of that. So there's a feature called remote control. This is actually already built into RDP. It's available on every Windows client, but Configuration Manager has its own unique version of this. So you can actually control the way the experience is for the user on the endpoint. So you can set the profile. I think this is Lee had mentioned this to me, where you could modify the profile to make the user's experience completely disappear. So in like default settings, you would require them to say, yes, you can connect to my system. There'd be a big green banner around their desktop that says, hey, someone's logged in. Like a sound would chime off, and then there'd be a pop-up to say, hey, there's someone connecting. But as admins, we can turn all that off. So be completely invisible, log into the session there, and the actual user is unaware that you're there. So I got approval and said, hey, I want to do this. And I was able to modify someone's settings to where I could control their system and kind of like shoulder surf them without them being aware of it. The other piece that's kind of unique and valuable to us is like the clipboard is shared. So anything that I'm watching them do work-wise, if they go to a password manager and grab a password out of it, I know it's on the clipboard. I can just have Notepad open on the side and paste that password in and have it ready. I think in this particular case, they wanted us to push a EC2 through their access that they had. And the user had like the Ubuntu client open, so I could Ubuntu Linux VM was running. So they already authenticated to it. So you can also lock their keyboard and mouse, and they were on a VDI, which I chose purposely so they couldn't poke it in the eye. So as soon as I locked their keyboard and mouse, I started playing with their access, and they ended up calling IT like in a panic because it was like the stereotypical, oh my God, my mouse is moving, I'm being hacked type thing. And they're like, okay, it's not real. But they ended up shutting down the system, and that was a good kind of like stimulation for them for their SOC. So
another kind of like example of how we would get into this position with the takeover attacks. There's another version of it basically where you can coerce and forward to SMB, the remote system authenticate with NTLM, take over the system, then add yourself to the database. So we were on a pen test, kind of, again, took the nuclear approach because we weren't required to be stealthy. We grabbed a list of all of the SCCM systems and coerced all of them and relayed all of them to all of them. And the only one that was successful, interestingly enough, was the site server was able to be relayed back to itself, which is typically not possible on modern Windows systems. We eventually found like a registry setting that Alad pointed out. It was called Disable Loopback Check, and this organization had disabled it, allowing us to do reflective relay to take over standalone primary site server. So we thought that was interesting too. All right. So how do we prevent this? Common recommendation is just to disable NTLM for the domain, right? Easy. We're done. All right. But in reality, it's very difficult to do this in an organization. There's a lot of legacy systems that rely on NTLM. Microsoft has had a really hard time killing it. They're doing a lot to move in that direction, but it's mostly with new versions of Windows as they occur. And I am guilty of making this recommendation in the past for sure. Definitely monitor, before doing this, but we're going to provide some alternative security measures that you can put in place instead of just flipping the switch. Also, this does not account for Kerberos relay attacks, which are somewhat new in the offensive space in the past couple of years, becoming more practical to implement in real operations. So what we're going to do to prevent takeover in some of these elevation techniques is implement a couple security features. Signing is one of them. It uses a shared key to create a hash of the message and then embeds that in the message to prevent tampering. Another is channel binding, or Microsoft calls it in some cases extended protection for authentication. And in that case, typically there's a channel binding token from the outer protocol. Like if it's encrypted with TLS, the channel will be bound to that protocol to prevent tampering. And then we're going to disable or block connectivity to protocols that don't support these features. And there are a couple protocols that we'll talk about where these features are not supported, and then it's just important to protect access to those ports. So here's kind of the hit list for takeover prevention. We're going to require EPA on ADCS to prevent ESC8 and the site database to prevent takeover 1. We're going to require SMB signing on all of the site systems in the hierarchy. We're going to disable and uninstall web client to prevent relay to LDAP. We're going to require LDAP channel binding and signing, and we're going to block unnecessary connections to those systems. Fair warning here at the bottom, these settings do impact connectivity. They can have performance impact. Audit them before implementing them, please. So the rest of this presentation is like step-by-step walking through screenshots, but that sounds really boring. So we are going to walk through it, but we're also going to kind of give you context from an offensive perspective in how some of these settings can be bypassed instead of just reading you step by step. But the first thing, as we're requiring EPA on ADCS that you need to do is require SSL. If you do not require SSL first, or in addition to requiring EPA, then an attacker can just contact the HTTP protocol because only HTTPS supports EPA in IIS. Next, we're going to require EPA. That's channel binding for the service in the CA. If we change this to accept, it will not prevent relay attacks if the coerced client doesn't support channel binding. I don't know which Windows version we would have to go back to find a client that doesn't, but it is possible potentially to coerce a client that doesn't support channel binding and then relay that to take over the site. And then we're going to repeat those steps for the certificate enrollment service in addition to the web enrollment service. And we're going to modify the web config and restart the service to finish those changes. And that will prevent relay to ADCS. Next thing we do is enable channel binding, extended protection for authentication on the site database to prevent that takeover 1 attack that we demoed just now. To do that, you open up SQL Configuration Manager, set force encryption to yes first. again, like if you don't set this, then only service binding is enforced, not channel binding. More research is probably needed to see how to operationalize a bypass for this, but feasible to still conduct a relay attack unless you require EPA and force encryption.
Does anything outside of SCCM require access to the site database? And might there be some things that might not support EPA?
Good question, and we'll get to that. So the question was like, what requires access to the site database, and do those things, require these protections? And we'll cover that when we talk about blocking those unnecessary connections. But then we're going to set EPA to required here. Third, we're going to require SMB signing to prevent a bunch of takeovers by relaying to various system roles in the hierarchy. And again, like it's potentially bypassed if you set this to like if the client or server agrees, then as the attacker in the middle, we can just negotiate to not have signing, in which case we can still relay our hearts away. We're going to disable and uninstall web client, particularly on the primary site server is very important. We have seen it enabled. It is not required for anything that we're aware of. And we've asked the dev team about this, and they didn't think it was required for anything either. If it's installed but isn't running, it still potentially can be triggered to start by an attacker. So something to be aware of as well. It has to be completely uninstalled from the system. And then we're going to block unnecessary connections to site systems. So to answer your question earlier, there's a list of ports that Microsoft has documented. It's actually like a very good and pretty complete document of all of the ports that are required inbound and outbound between the different systems. So definitely take a look at that link at the bottom there. But to prevent the takeover attacks, what we really need to do is prevent inbound and outbound SMB that is not required to and from the primary site server. Restricting inbound will prevent an attacker from coercing authentication from it. And outbound will prevent that any coerced authentication from being sent to like an attacker controlled system or an arbitrary IP address. On site database servers, we want to block and restrict access to SMB and MS SQL to prevent those other takeover attacks. And in that document, again, it says, which of these ports are required and for what systems. Obviously, like you'll need to check if there are any other integrations with SCCM in your environment to make sure any other like third-party applications are not blocked. But it should be relatively safe to block access to these ports from like general domain users. So the SMS provider, there's a takeover primitive where you can coerce authentication from the primary site server and relay to this role. It conducts the addition to the database on behalf of the user connecting to it. And this service just does not support any relay protection. So this one is especially important to restrict connections to. The only connections that really should be made to this system are by SCCM servers and SCCM administrators. The console that administrators open up communicates with this provider. But again, domain users don't really need this access. We want to restrict access to this service. If it's not restricted, then as attackers, we can still relay to it. In a lot of cases, we see this where the SMS provider role is on a server that also hosts client-facing roles. So like client devices contact a management point to fetch policy or distribution point to fetch software. If those are hosted on the same server as the SMS provider, then those ports kind of overlap. We can't just block them. So what we need to do is move the SMS provider role to a system that doesn't have any client-facing roles so we can restrict those ports. If we completely uninstall web client, we may not need to worry about this, but if it's reinstalled or triggered to start, LDAP channel binding and signing will prevent the credentials from being relayed to LDAP to do like a shadow credentials attack or a resource-based constrained delegation attack to compromise the domain computer whose corresponding domain object that we control. If only channel binding is required, then we can still relay to LDAP with start TLS. And if only signing is required, then we can still relay it to LDAP S because the TLS traffic is signed. That has changed now if your DCs are Windows Server 2025 or higher. But who's got 2025 or higher DCs already? Just one in your lab. Yep. All right. Quickly going to talk about client push installation. This is another method of elevation that you can do as an attacker. Kind of the legitimate use case for this technology is I'm an SCCM admin. I want to install the SCCM client software on a machine in my domain. SCCM has discovered computers in my domain by just like querying a domain controller. I go into the console, I right click, and I say client push install. The site server connects to the admin share on that computer with a list of configured accounts. And then if all of those fail to authenticate, it authenticates with its domain computer account, which we know has admin privileges on the SCCM database and all the other site systems. So that is susceptible to relay as well. This can be initiated manually, like I mentioned, through the console by right-clicking a device or a collection of devices, or it can be automatic. So as SCCM discovers new systems that are added to the domain by like querying LDAP, there's an option to just do this automatically, in which case there are some abuses that are possible. So Elevate 2 is one of these abuses. If automatic site-wide client push installation is enabled for like when new computers are added to the domain, SCCM doesn't do anything to prevent you from creating a fake device record with a self-signed certificate for a fake domain device, just with a regular domain account. So you can create this device record with an IP address that you control. And then when this is discovered, the site server will authenticate to that IP address, which can then be relayed, or in some cases cracked if the configured accounts have weak passwords. So to prevent this, we can disable automatic site-wide client push. We can patch the site server to make sure that the disable NTLM fallback option actually works. We can disable fallback to NTLM, or we can require PKI certificates for client authentication. But really, none of these would prevent like some newer attack primitives like Kerberos relay if somebody goes into the console, right-clicks the device, and manually initiates client push. So really, the recommendation is to move away from this technology and use another method of installing the client, one that pulls the client software from a server rather than initiate a connection to that device with a privileged account. So an example of this would be software update based with like WSUS, or GPO based installation of the client software. These are some ideas we've had and pitched to the dev team to prevent takeover. We realized recently none of these would prevent Kerberos relay. So, your mileage may vary, but these do work in a lab environment. If you add the the site server's domain computer account to protected users, it will be prevented from authenticating with NTLM. However, that is not something that Microsoft wants to support because disabling NTLM is hard.
Didn't they say, let us know how it goes? We try.
Yes, and so are we. Let us know how it goes if you do this, but not officially supported. Same thing. You can restrict outbound NTLM from site servers to only necessary systems. This one might be a little easier to implement. You can monitor this for a time, kind of get a baseline of what systems it's actually authenticating to, and then restrict that. Or you can restrict inbound to the systems that are able to be abused to grant the full administrator privileges. So your SMS providers or your site databases. But again, these solutions are only applicable to NTLM relay, not Kerberos relay, and are not yet an official recommendation supported by Microsoft. But to their credit, Microsoft did add official support for extended protection for authentication to the site database recently, and like announced it in the release, and are making pushes to implement security features by default in SCCM. So we are seeing some progress here. So hopefully there's some more guidance around this in the future.
And more on the EPA to the database. Like in my experience, I've never really seen it. I tried tweeting it out. I had one person say that agreed with me that they hadn't seen it either. I think we had one client actually try to deploy it, and then he had mentioned that it broke things. So even if it's supported, it seems like it's going to cause problems for them. So it seems like it's a difficult thing to fix. So just kind of keep that in mind as well.
Yeah, and I think it broke things because of the TLS versions that were supported by the database server. If you're not careful about matching those to what's supported by EPA, connectivity can break. So there's links to the documentation for implementing it and kind of like accounting for those concerns at the bottom of those slides. So definitely check those out and monitor it before flipping that switch.
Has Microsoft committed to adding EPA support to the SMS service?
The question was, has Microsoft committed to adding EPA to the SMS provider service? I don't think so. I haven't heard anything about that.
As far as I know, with the admin service, you have 3 different ways to authenticate to it. You have just the basic negotiate that we're used to. You have certificate-based authentication with smart cards, or you can use Azure-based authentication and have token auth. But that's really it. The actual service itself, it's not like an IAS application. You can't really interact with it in that way. I've tried to find different ways to do that, but as far as, and I've used the different types of authentication methods, and there just is not a way to prevent that type of attack at the time.
Yep, good question.
Cool. So now we're gonna jump into some credit attacks. So most of the stuff we've been talking about is taking over the entire thing, but where those situations may fail, we still have plenty more attack surface with this because SCCM seems to just kind of provide a lot of opportunities for us. SCCM has a ton of service accounts, and a lot of them are extremely old. One thing that's kind of difficult with them from like an administration perspective, and is kind of common with Microsoft services, is it's very difficult to rotate these credentials. So it's kind of like a set once and you don't come back to it type situation. Most of these are going to be part of the operating system deployment process or for managing policies and things like that, where the client is pulling that down from the management point. Probably the most common is a network access account. The name is descriptive of what it does. It's the whole point of it is to provide this new operating system that you're joining to the network some type of authenticated access to your enterprise environment so that they can start that operating system deployment process and start pulling the software down from the distribution point. So once they've got into that deployment process, the admin will set up these things called task sequences, and that's going to kind of have this granular control over how the operating system is deployed, what types of applications or what it might be. So if you want to have like a golden image deployment for each type of machine that's being joined, you can set that up with task sequences. Probably the most common one that we run into with this policy is it's a domain join account. So it's a foreign computer. You need to have some type of authenticated access or delegate the permission to join it to the domain. So you'll include that in the task sequence. And these are part of that is included with collection variables. So you can have it included in the task sequence itself, kind of hard coded there where it's going to be deployed, or you can have more control over like a device collection, which is a way for you to sort all the devices in your environment. And you can set collection variables there so that when the deployment goes through that, it will just use those variables for whatever task it's running at the time. So I don't think he's in the room, but Adam Chester a couple of years ago, because he was doing Adam things and got bored on the weekend and decided that he wanted to figure out how the secrets for these machine accounts were transferred from the management point to the client. And kind of what he discovered from that perspective is that it's not an encrypted, it's more obfuscated, because the key for kind of walking back the encryption that's in there is actually included in the request. So what he found is that he was able to spoof that kind of policy enrollment, pull the policy back, and then decrypt the credentials from that and kind of continue down that path. So included in that was the network access accounts. I should clarify that piece. We can request them from any management point. If we have some type of authenticated credentials, you can use a new computer that's joined. You can use the actual client that you have access to. So if it's an existing client, you can re-request policies. So once these policies have been pulled down to the client, they've used it to do whatever task they have done. They're actually stored locally, and they are just DPAPI protected blobs, and they're going to be protected by the system's master key. So I think this was posted by Dwayne a couple years ago, where he had found that it was stored in WMI, And then the really nice thing is, say you had a pen test or whatever, and we've come in and said, hey, you got to disable this network access account and remove it. So if you've done that, it's actually stored also in a SIM repository. So that blob will be in another location. So you have to clean it up twice. Just disabling it, removing it isn't sufficient. There's actually another location. So just completely remove the account from the environment at that point. So we have a couple demos that we want to run through. So we'll go through this. And the first one is we haven't really touched on that yet, but how many people have run into Pixie in an environment, abused Pixie? So yeah, so we got a few. This is Pixie Thiefy, which is written by Carsten Sandker. Yeah, so it's a re-implementation of what Christopher Penai had written when he had talked at DEF CON a couple years ago. So we'll run through kind of what that process looks like. So with the tool, you can kind of explore, and you're going to set the interface that you're going to interact with. And at that point, you're just trying to do kind of like a discovery on the network. So it's going to send a single DHCP request out. And if the DHCP server responds and says, hey, I have this, I will handle it and start that Pixie deployment process. I'm going to back up just a little bit. You'll actually see the request come in. And if we go to the top, you can see that Pixie has the option to set a password. I'm kind of like 50-50 on this, where I'll run with a certain thing. But if you don't actually set a password, it'll be kind of included in the request. Can you break it down a little bit more? Because I know you're a little bit more versed on.
Yeah, if you don't set a Pixie boot password, then there's basically a default that is used. And Pixie Thiefy will check for this default. And if it's present, then it will display a sharp SCCM command that can be used to request the policy secrets, including like network access accounts, collection variables, task sequences from a management point with the certificate that is in that media variables file that's decrypted with the blank password.
Right. So that was what you were saying there, with the blank password is on the Pixie media file, and it was able to decrypt it for that reason. So having the password in place, it's kind of an obstacle. You can actually use you can grab the hash for that credential and use hashget to attempt to recover it. And if at that point you're able to get the plain text password, you can kind of press on with this same attack. So make sure if you're defending it and you're locking it up, make sure the password is pretty strong. And then from the next point of view, we wanted to do a demonstration of is kind of requesting or is decrypting the secrets locally from the system. So here we're going to use sharp SCCM. We've elevated to admin. We have the correct permissions to interact with the system and kind of grab that system master key and then decrypt things from DPAPI. So you'll just run the local secrets command, and we're going to focus on WMI in this case. And it's kind of just as simple as that, where it'll identify the blob itself and decrypt it. And now you have the network access account password. So at this point too, if there were task sequences that were involved in this deployment process, it would be available here as well. Same with collection variables. If any of these credentials have been pushed to that system and during that decryption process, they would just be available here.
Yeah, and these network access accounts, they get deployed site-wide and to like every client device. So it's just like free creds for an attacker with an administrative context on a device. We've seen a lot of cases where SCCM was stood up. It appeared like a long time ago, and the network access account was an SCCM admin, the domain join account. It was like, it just had privileges for everything, and just leaving the key under the mat by pushing this to every single device.
So, and then from this perspective, we're actually going to do this remotely. So we have that access to the system. Say there's not an account that's available to us, so we can interact with the remote management point. So when we use the get secrets command, it's going to kind of parse the system to identify what its specific management point is at that given time, and then it's going to use the existing certificate that's local on there to interact with the management point and start that process and pull that policy down. And at that point, it's arguably the more OPSEC safe approach, because you're not interacting with DPAPI and you're still getting kind of the same end result of grabbing that credential. So kind of like a risk-based point of view is to start here and then go to DPAPI if you need to. So, but it's as simple as that. You'll be able to decrypt the creds and have access to them that way. So some more real world examples on this one. Did you want to take this one? This was
yeah, sure. So this is an example of a real BHE customer that through some kind of manual analysis, we found that there was a domain join account that was accessible via these Pixie boot attack primitives because it was used to join all these systems to the domain. It retained ownership of those objects, which in turn grants you the ability to take over the underlying computer. So another thing to just remember is those domain join accounts. They don't really require the ability to do anything but join computers to the domain. But because of how object ownership works, in some cases, they will become the owner of the resulting computer object in Active Directory. So if you don't revoke those access rights, then it's potentially possible to compromise those computers if this domain join account is compromised, for example, through Pixie boot.
I know I've used this kind of like this credential recovery technique when I was really locked down. The most recent assessment was there's just nothing in play. Like RC4 was disabled everywhere, and network connections between Windows clients was completely locked up. I could only really interact with servers at that point. They're extremely mature, and it was just a pen test. So at that point, I really didn't have to do too much, like as far as like burning anything for Privest. So I just asked for admin, and so they granted it. On the last day of the assessment, I had nothing. I didn't even have a secondary credential. I didn't have a computer account, nothing. But on the last day, they elevated to admin, and I was able to pull credentials from the task sequences in DP API. It had something similar to what this image looked like, where I had control everywhere. And then at that point, I was able to take that account, leverage its permissions to find the admin's workstations that I needed access to. And there was kind of just like the straw that broke the back. That was just the single point of failure in this extremely mature environment that just had this legacy kind of permission enabled. So, and then from the point of view with kind of like the network access account with the spoofed enrollment, I get messages on Twitter or just like Discord messages saying, hey, I used that technique to grab the network access account credential, and it was a DA, and it happens at least once a week, and it has done so for a couple of years. So the key thing with these is they are over permissioned, like excessively over permissioned, and it's just a legacy thing that people forget about, and I guess we can remind them. So
yep. So one thing to prevent this is obviously restrict the access that these accounts have, especially your network access accounts or accounts using task sequences. The network access account in particular just requires like read access to a distribution point. It doesn't need domain admin, but we see that it does have that in a lot of real world cases. What you can do to prevent these techniques listed here, we're going to walk through them a little bit. We're not going to walk through configuring PKI certificates for client authentication. That's a much more complicated beast. But we are going to talk about enhanced HTTP, which you can move to instead of using a network access account. So let's get into it. So to configure enhanced HTTP, we're going to come into this tab and enable it. Just note that, like from a offensive perspective, this does not prevent that attack I mentioned earlier, where you create a fake device record and then perform actions in SCCM on behalf of those devices. You would need to move to PKI certificates for client authentication in order to do that. Disable network access accounts. If there's one thing you leave with today, please make it this thing, or at least check them out, make sure they're not overprivileged. But to do that, we're going to navigate to software distribution in the console. We're going to click the big red X and remove them all. There's going to be a big scary warning that says, are you sure this could, if you remove this, the site might not function properly. That is not true. If you don't meet some of the requirements that like you actually need the network access account for, those are listed in the link at the bottom of this page. They're kind of edge cases. In most cases, the network access account is not required. So you're going to apply that, click OK. But we're not done, because those accounts now live on every client device. They don't get removed from all of those devices when you make this change. And like Garrett mentioned, they kind of live on in the WMI repository file, even if you delete these. So we need to also disable the account in Active Directory, or at least rotate the password. So if the NAA is not is removed in SCCM, but is not disabled or password changed in this way, then those credentials are still valid and they're still on every client device. Next, we're going to configure a strong PXE boot password. So if the password is, not crackable, like that's how we need to set it, because you can, if PXE is enabled, you can still like obtain a hash and crack it with Hashcat with Christopher Panay's extension. So it needs to be uncrackable. I know this is annoying for admins who are standing up tons of workstations all the time. It needs to be memorable. If you must set a memorable password, just please make it a long one. Please make it a passphrase. Please make it consist of multiple words, all the, NIST recommendations and stuff like that. But if the password is not set, then those PXE boot task sequences can be retrieved. The certificate can be used. We also found that, a friend of ours on the Bloodhound Slack found that the certificate that is in that PXE media file is the distribution point certificate, their ADCS certificate, if you're using PKI certificates for client authentication. So a lot of nasty things that can end up in those policies. And then we're going to restrict the permission to join machines to AD, setting machine account quota, and the user rights assignment. This will prevent a user from adding a machine account and then contacting a management point with that machine account to pull those policies and deobfuscate them to reveal those credentials.
And the key piece to that, though, is like that prevents new enrollments. So you can still reuse the existing ones if you're on the client and they're enrolled. You can still reuse that cert and still have that available to you. It's just kind of preventing the new ones.
So to kind of wrap this up, here's a link to the misconfiguration manager repo. All these techniques are documented in that repo, both the attack and defense techniques. The slides for this talk are also up there. If you want to check those out, there's the PowerShell script that you can run within your environment, and that will identify takeover methods and elevate methods that are possible in your environment for lack of these controls. So it can help kind of paint a picture, give you a map of where these could be problems to focus on. Detection, definitely take a look at Josh's talk when that comes out. The detect techniques that he discussed are in Misconfiguration Manager already, so you can take a look at those. So if these attacks are ongoing in your environment, how to detect them. New NTLM relay edges and Bloodhound will catch a lot of these techniques as well, so check that out. And then, if you want to find us, we hang out in the SCCM channel in the Bloodhound Slack. We love to collaborate with everyone, and thank you very much for coming.
Thank you, Chris. Thank you, Garrett. Any questions, guys? Yes, please.
You mentioned that the new NTLM relay detection in BHE was going to catch a lot of this. I didn't think they were including the SCCM stuff in the next batch. Do you have some notion of when that's coming?
I do not have a specific date for that, but I can tell you that the protections that are in place right now that are being captured for the new NTLM relay edges will catch the relay to ADCS, the relay to SMB. I am working on designs for future updates as well for like MS SQL and to actually, to pick some of these attack paths as well.
Okay, I have a question as well. For when you were talking about the domain joiner account, it's nice because you can check later and modify the ownership. But what happens when you need to restage a computer? You need to modify, you want to keep the object of the domain and you need to reset the password usually to do that and give these rights to the domain joiner account. It's really sensitive. Do you have any kind of suggestion for that?
So is the question like, what should the owner be set to after making that change?
Yes, what is because instead of, for the ownership, you can check later and remove the ownership of the objects that you are joining with the domain joiner.
Gotcha. But, so you can set the owner to domain admins. Jim Sikora's white paper, owner or pwned is what I would recommend to check out for the specifics on like how object ownership is handled when the owner is changed, when those objects are created. It goes into like a lot of technical detail about which scenarios are applicable. So I'd check that out.
Okay, but in the case that you need to restage a computer, you want to keep this object. you have to provide to the domain joiner account the right to reset the password of the object, the computer object. Or let's see what happened to me. Because if you want to reuse it, you need to change the password of the object. And then you have to provide these rights to DOM joiner, and it's like a sensitive account because it's exposed to the task sequences.
I gotcha. I'm not sure about the answer to that, but if you configure a strong PXE boot password to like protect that particular task sequence for unknown computers, shouldn't have that problem, hopefully.
Okay. I just said it's hard because the IT admins needs to type it. So,
right. Yeah. Okay. I understand, but
no, you say that
a necessary evil.
Thank you.
Yeah, I think in my experience with the PXE boot stuff, ideally you'd have it from a VLAN that we can't, like, basic users can't access. Like, ideally, I understand that that's kind of a huge lift, but we're also dealing with a service that is extremely old and arguably kind of deprecated. I know that MDT is kind of being retired. WDS is ancient. So that's, to me, that's kind of like the foolproof way of doing it, is just restrict it to specific VLANs where IT admins can interact with it. And then that could kind of solve your PXE password problem as well.
Yeah.
So,
yep. And there are a couple additional recommendations in Misconfiguration Manager, like restricting PXE to specific VLANs. This was kind of like the highlight reel of the things that are a minimum that you would need to do to prevent like takeover and mostly the relay stuff. But there are kind of more layers of security that you can apply that are detailed in that repo.
Okay. Thank you. Thanks so much.
Any other questions? I heard there were snacks, so
They're pretzels.
let's go
out there,
get them.
so.
Thank you, guys.
Thank you.